Alright guys, today I'm going to go over 3.1, 3.2, which is solving systems of equations. You guys have seen all of this before. You saw it in Algebra 1. Probably in your Algebra 1 class they really emphasized that you wanted to solve using either elimination or substitution. And then they probably showed you graphing as well. Maybe in Algebra 1 they wanted you to graph more. I'm not going to want you to graph ever. Never, ever. Graphing is a last ditch resort if we can't do anything else, that we only want to do if we literally cannot do anything else. The problem with graphing is that you make a little mistake or your line's not perfectly straight or something like that, and you're rounding the numbers off to something that they shouldn't be, and you're not getting exact values. So if we solve using elimination or substitution, we're going to get exact values. These are 4 problems that you need to bring in with you when you come into class on Tuesday. You need to have these done. Okay, you need to have these 4 problems done. When you are able to do all 4 of these problems, which some of you probably can do it without watching the video, when you can do all 4 of these problems, you can stop watching the video. So the 2 main ways that we're going to solve is using substitution and elimination. Elimination is going to be the easiest when the 2 equations are already in standard form. Standard form means that it's in the form ax plus by equals c, but it means that x and y are on the same side and the constant is on the other side. So if I had something like this, I would use elimination. So this is a very, very, very basic problem. My x's already match. I have the same amount of x's in each one. When you have the same amount, you're going to subtract. So I'm subtracting the bottom row from the top row. So I'm going to do 2x minus 2x is 0. 3y minus 2y is y. And 12 minus 10 is 2. Once I figure out what y is, I take this and I replace it back into one of the equations to figure out what x is. And I just solve. So 2x plus 6 equals 12. Subtract 6. 2x equals 6 and divide by 2. X equals 3. Now this is the really most important part. You always need to list it as a point. So our point is 3, 2. This is our solution. It's the one and only solution to this equation, okay? Or this system of equations. It's really important that you do that. Now with elimination, the numbers won't always match up. So on this one, my x's and my y's, neither of them match up. So what I'm going to do is I'm going to multiply everything in the top equation by the first number on the denominator. Meaning I'm going to multiply this equation by 5 so that my x's are the same. I'm going to multiply the bottom equation by the first number on the top, which is 2, just so that my x's become the same. So when I do this, I get 10x plus 15y equals 60. When I do this one, I get 10x minus 4y equals 22. Now the x's match, so I'm going to subtract. 10x minus 10x cancels out. 15y minus negative 4y is going to be 15 plus 4 is 19y. 60 minus 22 is going to give me 38. And then I'm going to divide by 19. Now once I get my answer, I got to take it and plug it back into the original equation. People always ask me, could I plug it in down here? Yeah, you could, but for me it's going to be easier up here. So I'm going to deal with the smaller numbers. And just solve, and we get x equals 3, and you need to put it as a point. So coincidentally, it had the same solution. That won't always happen. That was just a coincidence as the one before it. And that's our solution, okay? So when they don't match, you need to multiply them and get them to match. Fair enough? Substitution. I would use substitution if I had one of them in the form y equals or x equals and the other one in standard form. So substitution means that you're taking one thing out and you're replacing with what it is equal to. So y equals this, which means I can replace the y in my other equation with 2x plus 6. So I'm going to do 2x plus 3 times 2x plus 6 equals 12. Then I'm going to distribute. I'm going to combine like terms. And then I'm just going to solve. So I'm going to subtract 18 and divide. And then I just simplified. Negative 6 over 8 is negative 3 over 4. Take this and plug it into the original equation. And you can pick either one. Doesn't matter. That's my y part. This was my x part. So my answer is negative 3/4, comma 9 over 2. And that's it. So that's substitution. Now you can do substitution when they're both in y equals forms. So like the first example that I had on the problems today, the first one said y equals 3x plus 4. And the second one said y equals 1/2 x plus 1. This is still what y equals, so I can replace the y in the other equation. So I'm going to say 3x plus 4 equals 1/2 x plus 1. I don't like dealing with the fraction, so I'm going to multiply everything in here by 2. 6x plus 8 equals x plus 2. Subtract x, 5x plus 8 equals 2. Subtract the 8, 5x equals negative 4. Oh, sorry, negative 6. Divide by 5, x equals negative 6/5. Take this and plug it back in. So y equals 3 times negative 6 over 5 plus 4. Y equals negative 18 over 5 plus 4, which is the same thing as 20 over 5, which is going to give me 2 over 5. As a point, it's negative 6 over 5, comma 2 over 5. So that should have been your answer to that first problem on the first page. We're going to do a lot of these in class, so bring any questions that you have with you.